It's good that this author calls human constructs as artifacts. It's a nice word to use, because usually when you say artifact, you say it's a statistical artifact, which means something is appearing to be true just because the statistical analysis produces a correlation and so on without any causality, etc. Right? So we looked at the first and second steps. So it's defining the purpose and then define the principle for the rest of the design process. And third step of the design process is to develop the actual form of the artifact based on our initial judgments regarding what is needed to meet the design criteria and purpose. So ultimately you want to attain the purpose that you defined and define the function on how it's going to happen, and the design is going to have to have a form and do the function to meet the purpose, and then every design tends to have a criteria. The word developed here is here used to signify that there may, I don't know, I'm fumbling this, I'm hungry. The word developed is here used to signify that there may already exist artifacts to improve or build upon. A watch is made better, it's made a smartwatch, you have portable phones and then smartphones and so on. The fourth step is to utilize the artifact in the intended context or in a setting that is designed to approximate that context. Utilizing the artifact in the intended context is vital, as there may be various contextual factors that influence its performance. Moreover, it provides an opportunity to test theories about the context, linking back to traditional science. The application of the artifact can also cause learning that may inspire modifications in purpose and in design criteria. So I'm recording this on a laptop. The laptop is designed to do certain things, but maybe in a tropical country it gets too hot because it doesn't have enough cooling power, or I'm not providing enough space. The fan tends to be here on the bottom, so if you're not careful, it can get too hot, and so on and so forth. So design is one thing, but actual contextual use exposes many limitations, which are supposed to be reported back, let's say, to this company HP that sold me this laptop, so that HP can constantly track and keep providing updates, many times software updates. The fifth step of the design process is to evaluate the performance of the artifact against its design criteria and purpose. If the result of this evaluation is unsatisfactory, either the artifact must be further developed or the purpose and design criteria adjusted. Such accommodating adjustments of purpose and design criteria may be constructive if spurred by increased understanding of the context, but not if caused solely by demands to show improvement by reducing the gap between the artifact's actual and desired state. If you get a car and you're just not happy with how quickly it accelerates, that may not really need to an improvement, because the car is already designed for that and you paid for it. But if the car was promised that it would accelerate from 0 to 60 in 3 seconds like the Tesla does, and it doesn't do it, then you have to go back and say you didn't do what you promised. This latter situation is unfortunately common and constitutes in system terms a common systems archetype called eroding goals. So let's not dwell too much on the semantics. Design science is not merely about designing artifacts per se, but about making the design of artifacts scientific, and thus about solving real-world problems scientifically. Following a systematic and transparent design process as presented above is a requisite for that, and building and evaluating artifacts to address problems can be as scientific as theorizing and justifying theories. So you understand the difference, we'll say in a minute. Although both processes may appear similar, and some even argue that theories are artifacts in themselves, they are fundamentally different in perspectives and entail differences in principles for assessing scientific quality. So we are talking here as if there is a physical device. An artifact is a physical thing which has a form, a function, and then it's designed to perform that function. But you also have metaphorical situations in sustainability and adaptation, where you are devising adaptation policies, principles, you're funding things for people to do certain things, and then you have to worry about maladaptation, which occurs over time. So if you have adjusted or adapting to a risk that's there now, it may become maladaptive with changing risks, or you may just have not planned well for the risk that's already there. So it's not a physical thing, but there is still design, there's still purpose, function, desired design for the process. There is a form of the artifact which is in terms of the actions, and there is maladaptation. So it doesn't have to be physical. Okay, so whatever the way you approached the artifact, purpose, design, function, and performance, then you need reliability of the artifact, which has to be validated, and workability has to be ensured. So the quality of traditional science is commonly assessed in terms of the reliability and validity of the result. Reliability refers to the degree of consistency of empirical results between different researchers or by the same researchers on different occasions. In other words, it refers to the degree to which these results are independent of unintentional circumstances. So whatever is the context, you have to be able to reproduce the results. Reproducibility, which is you can call it as reliability. In other words, it refers to the degree to which these results are independent of unintentional circumstances. Validity, on the other hand, refers to the accuracy with which an empirical description of a particular phenomenon represents the theoretical construction that it is intended to represent and captures the relevant features of that phenomenon. I think you get an intuitive sense, so let's not try too hard to come up with examples. In other words, it refers to the degree to which the empirical results are interpreted in an adequate manner. So remember, it's a traditional science, so you are looking at something and you are observing it, you are taking data and providing an interpretation, and then somebody else has to look at it and come up with the same interpretation. Okay, so here is good reliability but validity. So all the points are there in the same cluster, but here, in the sense that it's not near the bull's eye here, so validity is low. Poor reliability but good validity, so you have come closer in terms of reproducing, being in the same target area, but reliability is poor, so you have the spread. That's not good. IMS too schematic. So if you hit the bullseye all the time, then you have good reliability and good validity. Okay, let's leave it there. Reliability depends essentially on transparently describing the research procedures, making it possible to distinguish at least three types of reliabilities. Reliability as a single research method, continually yielding an invariable result. So anybody follows the methodology will come up with the same result. Reliability as stability of a result over time, so that even if you do the same experiment again and again over time, same person, same methodology, you will get the same result. Reliability as similarity of results within the same period using different data. Let's say you did something as a tendency of human behavior. We talked about biases. You get the same result when you do it with different populations of human beings. I don't know. Think of the example yourself. The first two types of reliabilities are not particularly useful in assuring quality when researching complex human environment systems. So if reliability is a single research method continually yielding an invariable result, or reliability as stability of a result over time, then the complex human environment systems may not get the result, intended function out of such an artifact. The first suffers from the fact that it allows a single flawed method to continuously generate erroneous results, and the second for the fact that the world is constantly changing and the elements and dependencies under study are impossible to isolate. What is left is reliability in the sense of corresponding results by different research methods, which is commonly called triangulation. This warns us that use of metaphor of triangulation often connotes naive ontological and epistemological assumptions that it is possible to pinpoint reality by applying multiple research methods in the same way that a surveyor pinpoints a geographical location. Okay? Many social science philosophy kind of words with ontological and epistemological. Although the metaphor of triangulation itself is misleading, diverse data that lead to similar conclusions may still render us a little more confident, as different data have different biases. This assumes, of course, that the methods used do not share the same bias. We'll come back to practical applications so this theory can be put into practice so that we know what we are talking about. So let's leave this here because I do need to go and eat, and I'm feeling a bit hungry. It's already more than 11 minutes long. So we'll come back and follow up on reliability, validity, and workability. The workability of the artifact becomes very critical, because if it's reliable and validated but it is not workable, then obviously you have created something that is not useful or usable. So we'll come back and look at what we mean by workability after we have figured out reliabilities of different types and validity. Okay, see you in the next podcast.